In Java, a read-write lock is a synchronization mechanism which allows multiple threads to read a shared resource concurrently, but only one thread can write to the resource at a time. This mechanism is particularly useful when the resource is predominantly read-heavy rather than write-heavy. Let's understand this by visualizing an example. Imagine that there is a booking system using which you could book seats in a bus. There are two main functionalities when it comes to the seat selection. First is you should be able to view the available seats, and the other one is where you can book a particular seat. So in the image that we have threads from 1 to n which want to view the available seats and threads from 1 to n which want to book a seat. As per what we have learnt already, for any thread to be able to do some processing, it needs to acquire the lock. So let's assume that thread 1, which wants to just read the seat availability, acquires the lock and proceeds with it. Please note that this is not efficient. Why so? It is because there are other threads which also wanted to just read the data. Since they are not writing anything, there would not be any concurrency issue involved if more than one threads acquire the lock and do its processing, and this processing is just to read the data. So how about if we could somehow club the reader threads together, and it would be much efficient, right? And yes, certainly it would be very much efficient, and the read-write lock indeed does the same thing. After some time, the read threads are done reading the data, and at some point of time, the read lock is released. Once released, either of the writer threads could acquire the write lock and do their processing. Effectively, in the case of a read-write lock, one writer thread could get hold of the writer lock at a time, or multiple reader threads could get hold of the read lock at a time. Please note that we have two locks, one for the reader, other for the writer. So even though we have two different locks, two different objects, only one can be acquired by a thread or a group of threads at a given point of time. So either read lock is used by n threads or write lock is used by one thread, but it can never happen that both the locks could be used at the same time ever. So what we have seen essentially that there are two kind of threads. The first category is that of the reader threads. The second category is of the writer threads. Since reader threads are not mutating anything in the data, they are safe to run together. And that is the reason that all these reader threads could acquire the reader lock at once and do their processing. When it comes to the writer thread, this could not be the case because writer thread is going to change something to the data. And that is why only one writer thread is allowed to acquire the lock. So in such scenarios wherein you have a very much clear condition of reader versus writer, this is one such lock which could be used in such cases. And please note that you would gain performance if your application is, or rather if your use case is read heavy, not a write heavy. So now we will have a quick code demonstration to see how can we make use of the read-write lock. So as part of the code demonstration, what we are going to build is a class which will have a counter. There would be a couple of reader threads and a writer thread. The writer thread will try to increment the value and the reader threads will try to read the value, and we wish to do so using the read-write lock. So let's implement it. We will create this class in the logs package. Let's call this as shared resource. We will have a variable, let's call this as counter, the value is 0. Then we will have the read-write lock. So read-write lock, let's call this as lock, and we will be instantiating the object of new reentrant read-write lock. We have the first method which is supposed to increment the value, and the way we do this is we acquire the lock. So lock dot write lock, dot lock, and we will have the implementation inside a try block. Finally is used to unlock the lock that we have acquired previously. And what we will do is we will increment the counter by calling counter plus plus, and we will print a message. The message could be something like thread dot current thread dot get name, and it writes and the value, that is counter. So this should be it for the increment method. Now let's implement the other method as well, which is going to get me the value of the counter in a given thread. And idea is that this is supposed to be made use of by the reader thread. Let's minimize this one. Now back to the implementation of the get value. First we try to get hold of the read lock and call lock on this one. Next we will have the try block, and inside the finally we will close the read lock that we have acquired by calling the unlock method, and we will read the value for the counter. So let's have the message like thread dot current thread dot get name and reads counter. So this should be for the get value method. And for the read write lock demo, we will create another class. So let's call this class as read write lock demo, and we would have a main method. Inside the main method we create the object for the shared resource, and we will create a couple of reader threads. So let's do that. So for I, and inside the loop what I do is I create the reader thread. So new thread, and for int j as 0, j less than 3, j plus plus resource dot get value. And now let's assign a name to this thread. So let's call this as reader thread and pass the value as I plus 1. Now we will start this thread. So let's call dot start on this one. For the writer thread, let's create one. So thread writer thread new thread, and we do this for 5 elements. So share resource dot increment, and likewise we will provide a name to the writer thread. So let's call this as writer thread, and let's start this thread. So let's run this code and see how is the outcome like. Alright, so what we see is that we have reader thread and there is another reader thread, the two that we have created, right? And they are reading a value of 0 initially because the writer thread has not been executed yet. The value remains to be 0, the initial value. Then we have the writer thread, and what the writer thread is doing is it's going to increment the value 5 times. And as a result, what we say is the value gets incremented to 5. Now we have the reader thread, and the reader thread reads the value, and the value that it's reading is 5. Again, the reader thread is invoked and it's reading the value as 5. So this is how you could make use of the read write lock if you have such a use case wherein you want to bifurcate the lock acquisition for readers and writers separately. So that should be it for the code demonstration. Let's complete this section of read-write lock by learning about the behavior of wait queue in the read-write lock. So let's visualize how the wait queues are arranged and managed in the case of a read-write lock. In the case of a read-write lock, there would be two types of threads in the wait queue. One type of threads are those which want to read the data, and the other type is which want to write the data. Let's say that initially there is one writer thread and two reader threads. In this case, the reader threads will be allowed to acquire the read lock. This is done because it's efficient. Essentially, what you are allowing is two threads to be executed as compared to the one. Once all these reader threads are done with their operation, the writer thread waiting in the same queue is allowed to acquire the write lock. What happens in the scenarios when there is a writer thread waiting in the queue and the reader threads keep on coming to the queue? Should they all be allowed because it's faster to execute? Well, if we do so, the writer threads will be starved, and this is not good. So this kind of low level optimization is taken care of depending on the type of implementation you choose for the read-write lock. For example, reintent read-write lock is one such implementation. The key takeaway here is that read-write locks are optimized for reading and writing operations in the most efficient manner possible. And you as a developer should be good to make use of this lock without much optimization or configuration concerns. So whenever you have such requirement, consider making use of this lock.